All right, guys, forces in motion. So in this one, we'll do look at a few questions, brief introduction on like concepts like inertia, velocity, force, friction we need to be familiar with. We'll go over just the brief stuff that you need to know about each of Newton's laws, um, and a few things on other important concepts, as well as force and net force questions, which you are likely to see. Okay, so be familiar with the basics of Newton's laws, as I just said. Two primary characteristics of projectile motion. Yes. A Newton of force equals what? Yeah, we will definitely go over that, and you definitely need to know that. What is the equation for net force? As I said, we'll go over force and net force questions. And then finally, gravity follows the inverse square law. Do we know what that means? Okay. Okay, so these four concepts. Inertia is the resistance to change in motion. Velocity is the speed of an object in a specified direction. Force is any influence that causes an object to change its shape or its state of motion, while friction is a force acting in the opposite direction of motion when two objects come in contact with each other. Probably the one that people get wrong the most is being able to differentiate velocity and speed, and knowing that velocity is the speed of an object, but also in a specific direction. Okay, Newton's laws. This is a busy slide. So we're going to do the first three laws as well as the law of universal gravitation. Okay. So Newton's first law states that an object either remains at rest or continues to move at a constant velocity unless acted upon by a force. This sets a qualitative but not a quantitative parameter. Okay. Second law does involve formulas for force, but you're not going to be tested on those. Okay, so you do need to know that the second law states that the rate of change of momentum of a body is directly proportional to the force applied, and this change in momentum takes place in the direction of the applied force. Okay, so that's an earful, but you just have to have that concept locked in your mind. Newton's third law states that there is no such thing as a force that is not accompanied by an equal and opposite force. Perhaps the easiest one to remember there is that third one. And then Newton's law of universal gravitation, which it looks like slightly the last part of what we wrote got cut off, but I'll make sure we go over it here. So, law of universal gravitation states that a particle attracts every other particle in the universe using a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, so that's also quite a bit to take in. But we should also mention gravity is most accurately described by the general theory of relativity proposed by Albert Einstein in 1915, which describes gravity not as a force, but as a consequence of the curvature of spacetime caused by the uneven distribution of mass and energy. Okay, so those are the four. Most likely that's just a little bit of memorization that is necessary, so that you can just be able to talk in a sentence or two at the most about what each of these laws are. And if you can differentiate them, that's all you need. We don't need to worry about formulas and how to apply them. Okay, projectile motion. That was one of our questions, right? Okay, the two characteristics of projectile motion. So they are first, the horizontal component of velocity does not change. Second, the vertical acceleration due to gravity affects the vertical component of velocity. Okay, examples of projectile motion that are pretty common are objects that are thrown, such as balls usually, or rocks possibly. Uh, balance forces, these occur when an object moves at a constant speed. The force of gravity between two objects is proportional to the product of the masses of those objects. The more massive the objects, the stronger the force of attraction, but regardless of their mass, both objects will experience the same size force. Also would like to know here, as an object falls, its speed increases because it's being pulled on by gravity. The acceleration of gravity near the Earth is negative 9.81 meters per second squared, and velocity is that same number, negative 9.81 meters per second squared, times time, or what's usually written as v equals gt. Right, with g being gravity, right? And a Newton of force. This will show up more in actual problems, but you need to know this concept. A Newton of force is 1 kilogram times meters per second squared. And we get to apply that concept right here. Okay, so here's our first question. We got two of these, two questions. So a 10 kilogram object is moving to the east at 20 meters per second squared. What is the net force acting on this object? Okay, so first we need to know net force equals mass times acceleration, right? Fairly straightforward equation. But that's an equation you have to have memorized to be able to answer this question. So therefore, we're just going to multiply the two numbers together, right? And then we just go 10 times 20 equals 200 kilograms times meters per second squared. And remembering that concept down at the bottom, a kilogram times meters per second squared is a Newton, right? And so the correct answer that you're going to see is actually 200 newtons. That will be the correct answer choice for this type of question on the test. The next question, if you increase the distance between two objects by a factor of 2, what happens to the force between them? Okay, and this is that inverse square law, which was one of our questions. And we'll look at the questions again here at the end. So gravity follows an inverse square law. So therefore, if you double the distance, right, which is what the question says, right? If you increase the distance by a factor of 2, that's saying we're doubling the distance, then the force is the inverse of 2, right? So 2 or 2 over 1, and then we flip it. The inverse is 1/2 squared. And 1/2 squared is just 1/2 times 1/2, and that equals 1/4 or a quarter, right? And so that's how you do that type of problem. All right, so those are our force and net force example questions. Important to know how to do those. And then finally, we jump back into our questions again. And so it's a great time to hit your pause button and test yourself out on each of these concepts and make sure you're comfortable with it before you head into your exam.